You know, every single day, our planet sees millions of lightning bolts flash across the sky. It's one of nature's most common sights, and yet it's also one of its most extreme. But have you ever stopped to wonder what's really going on inside a storm cloud to unleash that kind of raw, incredible power? Well, let's get into it.
To try and wrap our heads around the scale we're talking about, just look at this number. A single bolt of lightning heats the air around it to 30,000 degrees Celsius. That is 5 times hotter than the surface of the sun. All of that energy just unleashed in a fraction of a second.
Now, as incredible as that sounds, the basic physics behind lightning are actually pretty familiar. I mean, at its heart, lightning is just a massive electrical discharge. It works on the exact same principle as that little static shock you get when you touch a doorknob, just, scaled up to an almost unimaginable level. So the real question is, how does a simple cloud build up that much static electricity?
Well, it all starts inside a thunderstorm with 2 really simple ingredients: water and ice. The storm cloud itself starts to act like a giant electrical engine, separating positive and negative charges to create this enormous voltage difference. Here's how it works. You've got these powerful updrafts that carry warm, moist air and tiny water droplets way up high into the freezing parts of the atmosphere. As they go up, they form this chaotic mix of small ice crystals and bigger, heavier chunks of hail. And inside that churning cloud, all these particles are just violently colliding with each other. And every time they collide, electrons get stripped away.
And all this crashing around leads to a really critical process called charge separation. The lighter ice crystals, the ones that lost electrons, are now positively charged, and they get carried all the way to the top of the cloud by those updrafts. At the same time, the heavier hail, which gained all those electrons, becomes negatively charged and falls down toward the bottom of the cloud. And just like that, the cloud has basically turned itself into a giant natural battery, with a positive pole at the top and a negative one at the bottom.
So now you have this super powerful negative charge building up at the base of the cloud, and that has a huge effect on the ground right below it. It actually repels the negative charges on the Earth's surface, pushing them away. This causes the ground directly under the storm to build up a strong positive charge. What you end up with is this huge electrical imbalance, a massive tension between the cloud and the ground just waiting for something to happen.
Okay, but wait a second. This brings up a pretty big question, right? We all know that air is normally a great electrical insulator. I mean, if it weren't, we'd be getting zapped all the time. So how in the world does electricity manage to jump across that huge gap? We're talking kilometers between the cloud and the ground.
Well, the answer is just raw power. The electrical field between the cloud and the ground eventually becomes so incredibly strong that it physically rips electrons right off of the atoms in the air itself. This process is called ionization, and it basically forges a superhighway for electricity where there used to be a roadblock. The air goes from being an insulator to a conductor, and at that point, a lightning strike isn't just possible, it's inevitable.
Now, the strike itself seems instantaneous, doesn't it? But it's actually a pretty complex, multi-stage event that unfolds in just a few milliseconds. So let's break down the anatomy of the bolt step by step. It all starts with something called a stepped leader. Think of it as a faint, usually invisible channel of negative charge that kind of zigzags its way down from the cloud, looking for the path of least resistance. As it gets close to the ground, the positive charge on the surface reaches up to meet it through what are called upward streamers. These usually come from the tallest objects around, like a tree or a building. And when one of those streamers connects with the leader, bam! The circuit is complete, and that triggers the main event, the return stroke.
And this is the part that is really counterintuitive for most of us. That brilliant, blinding flash of light that we all call lightning, that is the return stroke. It's a massive surge of current racing from the ground up to the cloud along that channel that was just created. So the bright flash you're actually seeing isn't coming down, it's racing up.
And it's that incredibly fast upward return stroke that gives us thunder. The air in that channel is heated so intensely and so quickly that it expands explosively. That creates a powerful shock wave that we hear as a clap or a rumble of thunder. And of course, since light travels almost 1,000,000 times faster than sound, you always see the flash long before you hear it.
You know, it's interesting, we always think of that classic lightning bolt hitting the ground, right? But it turns out, that's actually the least common type of lightning. Most of these electrical discharges happen entirely within a single cloud. That's called intracloud lightning, or they jump between 2 different clouds.
So why does all this matter? Well, it's more than just a cool science lesson. Lightning is a seriously powerful force that has a huge impact on our planet and our lives. It acts as both a force of destruction and maybe surprisingly, a force of creation.
First off, the danger is incredibly real. On average, lightning kills about 24,000 people around the world every single year, and it injures hundreds of thousands more. So, understanding how it behaves is absolutely crucial for staying safe.
And knowing the science leads us directly to really practical advice, like the 30-30 rule. It's simple. If you see a flash and then hear thunder in 30 seconds or less, the storm is close enough to be a direct threat, and you need to find shelter right away. And since lightning can strike pretty far from a storm's center, it's a good idea to wait at least 30 minutes after you hear the last clap of thunder before you head back outside.
But it's not all destructive. Lightning has another side to it, a creative one. The intense energy in a lightning bolt is actually powerful enough to break apart the super strong bonds of nitrogen molecules in our atmosphere. This creates compounds that then fall to the ground with the rain, acting as a vital natural fertilizer for the soil. In fact, some scientists even think that billions of years ago, this very process might have provided the essential chemical building blocks that helped spark life on a young Earth. So when you think about it, a lightning strike connects everything from that small zap of static electricity to a force that literally fertilizes our world. It's a brief, powerful reminder that the ordinary air and water around us can combine to create one of the most extreme and dynamic events on our entire planet.